In example 2, we need to solve for theta such that 0 degrees is less than or equal to theta is less than 360 degrees for part A, and then we've got 0 to 180 for part B. Okay, so we're not talking about principal values here, that's for sure. We've got 0 to 360. Let's see if we can figure anything out from this inverse sign here. The inverse sine of -1/2 should give us that angle. Let's see here. So let's go back to our calculator. We'll use that tool to help us think about this. And we've got -30 degrees is what our calculator spits out at us. So some students just stop here and say, ha, I got it, this was easy, no big deal. But -30 degrees is not between 0 and 360. What we could do is we could add 360 here, find a coterminal angle. Of course, those will be in the same spot. Then we'll have something that might look a little better. So -30 plus 360 is 330. That's in between here. That's good. But there is another angle, is what I mean to say. Not there are. There's only one other angle that will actually work here. So this is a tricky situation here. Let me show you what I'm thinking about here. I'm going to draw a little coordinate plane. And here is 330 degrees. And you will note that this distance here is -1/2. And that's the y distance. We're talking about sine here, and let's imagine we're on the unit circle. So let's call that radius, or the hypotenuse here, 1. And so we could say for sure that if we're looking at this angle here, that the opposite over the hypotenuse, or y over r, is definitely -1/2. There is another angle that has that same situation that your calculator will not lead you to, because it solves for principal values only. This other angle is in quadrant 3, and this radius will stay the same here, that's still 1. There's another angle that has a y value of -1/2, and that's really what the sign is about here on the unit circle. So we have to find this angle, and this angle right here, you can tell that our reference angle is 30. So to find this angle, we need to go 180 degrees and then 30 more. So the solution here could be 210. There's a very easy way to see if you are correct. Try it in your calculator. You need to be in degree mode, and then we're going to try the sine of 330. Hit enter. It should give us -1/2. So all we're doing is trying to find this value that makes this equation true. That's it. And then also the sine of 210, if we've done this right. It's kind of easy to make some mistakes with those 30, 60, 90 triangles, so just double check yourself and make sure. And we totally have -0.5 here. So these two angles between 0 and 360 both have a sine of -1/2. We don't have to worry about quadrants 1 and 2 because that value is negative, and any y value up here is going to be positive. I really like the next question because it causes us to think a little bit deeper about the types of solutions we might get, and I'm going to try to do this with a little u substitution for you. So we're going to look at this and we're going to say, well, let's just do the tangent of u is equal to 1. So we're going to let u equal 5 theta. Now keep in mind, when we introduce a variable, we need to, that might help us, but we need to go back to this value of theta. So let's think to ourselves, and we're going to go 0 to 180 for right now, but that's for theta, not for u. So let's get a few values that will work here for u. This is the tangent of an angle to give us a ratio. And if you remember your tangent ratio, it's y over x, or opposite over adjacent. And so there's a couple points on the unit circle, and I'll just draw that real quick here. You can use your unit circle for reference if you'd like. But one of those is 45 degrees. So at 45 degrees, this point right here has a x-coordinate of √2/2 and a y-coordinate of √2/2. So when you take y over x, you just get 1. So 45 degrees will balance this equation right here. So one of our options is maybe 45 degrees, and that would be u is equal to 45. Let's see. What else could u be equal to? What about down here? This one would have a y value of -√2/2. and an x value of positive root 2 over 2. Nope, excuse me, negative root 2 over 2. My fault. Go left and go down. Those are both negative. And so if we take a negative root 2 over 2, y over x, negative root 2 over 2, we get positive 1. And this angle all the way around there is 225 degrees. So 225 degrees might work. Now you might be wondering, Mr. Balsa, you are not paying attention to your own advice. You just listed an angle measure that is outside of 0 to 180. Ha, gotcha. Well, that's for you, not for theta. Remember that we set is equal to 5 theta, so we haven't solved for the variable just quite yet. If we substitute u and 5 theta back again, we've got 5 theta could be equal to 45 degrees, 225 degrees, and we might need to build our list a little more. To solve for theta, we're just going to take all these values and divide them by 5. So 45 divided by 5, if we did that here, that would just be, gosh, I think that's 9. So that would be, theta would be 9 degrees. So you can see we're getting some smaller values here. 225 divided by 5, that's 45. So we've got 45 degrees. And these numbers are fairly close to 0. They're definitely between 0 and 90. And we need to solve for 0 to 180 here. Try to move this up. Hopefully you can see it a little better. So we need to build some more angles for u. How we build angles for u is we just find coterminal angles of these two. So if we added 360 to 45, we'd get 405. We're going to need to divide that by 5. And we're just going to keep playing this game until we run out of room, until we get something past 180. So let's see where we're at here. Well, we're at 81. All right. Let's see here. We're going to have to build another one. So we did a coterminal angle of 45. Let's do a coterminal angle of 225, and that would be 585. And remember, we're solving for theta, so we'll need to divide that by 5. 117. We'll keep going, so we'll take 405, add 360, those are coterminal, divide by 5, we've got 153, getting closer. We need to check one more, so we're going to go 585 plus 360, that's 945, then divide that by 5, that's 189. And that is now outside of our original range up here, or our domain for theta, if you will. So we'll scratch that from the record, but all of these are between 0 and 180 degrees. And each one of these, if you substituted that back in here for theta, you would find that it's true. So if you did tangent of, let's just pick one, how about 117? So it's 5 times 117, remember our original. And then you could hit enter, and that is indeed 1. So all of these values here make this equation here true.